Assalamu alaikum everyone. My name is Mahdi Araf. I am a student in Daffodil International University, currently studying in Computer Science and Engineering. Today, I will be giving a presentation about process synchronization. The last four digit of my ID is 1071. So let's get started. At first, we will be talking about the table of contents. At first, we have introduction to process synchronization, common synchronization problems, producer-consumer problems, critical section problem such as mutex and semaphore, and then we have bounded buffer problem, dining philosopher problem, and last but not the least, conclusion. At first, we have introduction to process synchronization. Let's see what is process synchronization. Process synchronization ensures multiple processes execute concurrently without conflicts when sharing resources. Why it is needed? Prevents race conditions and data inconsistency, avoid deadlocks and starvation, ensures safe resource sharing. Real life example is banking system, preventing double withdrawal, operating system, CPU and memory management, multi-threaded application such as thread coordination. Next, we have common synchronization problem. In common synchronization problem, race condition when multiple process access shared data simultaneously leading to unpredictable results such as deadlock. Processor wait indefinitely for resources held by each other, causing a system freeze. Starvation. A process waits indefinitely become other higher priority process keep executing. Critical section problem, ensuring that only one process accesses a shared resources at a time to prevent conflicts. Next, we have producer consumer problem. What is producer consumer problem? A producer consumer problem is a synchronization problem where a producer generates data and a consumer uses it, both sharing a fixed size buffer. The challenges of producer consumer problems are buffer overflow and buffer underflow. What is buffer overflow? Buffer overflow is when the producer adds data while the buffer is full. And what is buffer underflow? When the consumer tries to access data from an empty buffer. What is the solution of this buffer? The solution could be use mutex for mutual exclusion, use semaphores to track empty and full slots, synchronize producer and consumer to prevent conflicts. Next, we have critical section problem. What is critical section problem? A critical section problem is a problem that arises when multiple processes access shared resources simultaneously, leading to data inconsistency. Condition for a solution: mutual exclusion. Only one process can be in the critical section at a time and progress. No unnecessary blocking. A process must enter the critical section when no other process is inside. Bounding waiting. What is bounding waiting? A process should not wait indefinitely to enter the critical section. Next, we have mutex and semaphore. What is mutex? Mutex is mutual exclusion, a binary lock that allows only one process to access a critical section at a time. Process must lock before entering and unlock after existing. Used for exclusive access, such as thread synchronization. Now, what is semaphore? A counter-based synchronization mechanism can be binary, 0-1 like mutex, or counting tracks multiple resources, used to manage multiple process accessing shared resources. Key difference. What is the key difference between mutex and semaphore? Mutex only the process that locks it can unlock it, and semaphore can be singled by a different process. Next, we have bounded buffer problem. What is a bounded buffer problem? Bounded buffer problem is a problem that synchronization problem where a fixed size buffer is shared between a producer and a consumer. Challenges of bounded buffer problem: buffer overflow and buffer underflow. In buffer overflow, producer adds item when the buffer is full, and in buffer underflow, consumer tries to remove items when the buffer is empty. For this problem, solution can be mutex for mutual exclusion, semaphores to tag available slot and field slot, proper synchronization between producer and consumer to prevent conflicts. Next, we have dining philosopher problem. What is a dining philosopher problem? A dining philosopher problem is a problem, a synchronization problem, where n philosophers sit around a table with n forks. Each philosopher thinks and occasionally needs two forks to eat. Challenges of dining philosopher problem: deadlock and starvation. In deadlock, philosophers may wait forever for forks, causing a system freeze. Starvation: a philosopher may never get both forks if other keeps eating. Solution approaches: resource hierarchy. Philosophers pick up forks in a specific order to avoid circular wait. Arbitrary arbitrator waiter, we can say, otherwise it is a waiter, a central authority that controls access to forks. Semaphores for mutual exclusion and to prevent conflicts. Next, conclusion. From the presentation, we understand that the process synchronization ensures safe execution of concurrent process sharing resources. It prevents issues like race condition, deadlocks, and starvation. Tool like mutex and semaphore helps managers access to shared resources. Problem like producer, consumer, bounded buffer, and dining philosopher highlight the need for synchronization to maintain system stability and efficiency. That is all for today. Thank you. If you have any question, please feel free to ask. Assalamu alaikum.